Okay, question number 7. A greengrocer displays apples in trays. Each customer selects the apples he or she wishes to buy and puts them into a bag. Records show that the weight of such bags of apples may be modelled by a normal distribution with a mean of 1.16 and a standard deviation of 0.43. Determine the probability that the mean weight of a random sample of 10 such bags of apples exceeds 1.25 kilograms. Okay, so for the first part, it is a normal distribution, we're told that, but we're now dealing with the sample mean here. We're talking about 10 such bags. So the sample mean is going to be normally distributed with a mean of 1.16 and a standard deviation of 0.43, so we write it like that, and the sample size is 10. This is really interesting because typically when we're doing questions with the sample mean, they'll come up as the second part of a normal distribution question. This one we're straight in right at the start with it. Okay, determine the probability that the mean weight of a random sample of 10 such bags exceeds 1.25. Well, again, I'd very strongly recommend that you draw a diagram. The sample mean itself is distributed with a mean of 1.16, and we're asked to find the probability that the apple exceeds 1.25, which is there. Now, this does constitute some working towards this question, but again, we're going to be going to the calculator to get assistance with this. So we're just going to make sure, I'll get it back into the correct menu. So we're going to go to Stat, we're going to go to a distribution, and we want the normal distribution. But I'm just going to make sure that everything's written out on the page before we do that. So what we're actually wanting here is we're going to use the NCD function for this. I need the lower value, the upper value, the standard deviation, or the standard error as it's going to be in this case, and the mean. So I'm going to take great care with this one, and I'm going to show you what I do. So the lower value is 1.25. The upper value will take as 9999. The standard error here is effectively what is the standard deviation of the sample mean. Now that's going to be 0.43 over root 10. And take care to enter that like that. The mean is 1.16. Okay, so again, I've written that before I try and enter it, because if I try and do the two at once, my worry is that I'm going to make a mistake. So 1.25, 9999. For the next part, it's 0.43 divided by the square root of 10, so shift root 10, comma, and then the last part, the mean, is 1.16. Close the brackets, and my answer is 0.254. Okay, now again, I would suspect that most students here are going to fall either with 0 marks or 4 marks, because it's very difficult, again, unless you're being very clear with what you're after here. And if you show some of this working, I'm sure that you'd gain some method marks, but it's not easy to go between the 0 and the 4 marks. Take great care, and really, really take great care with that standard error there as you're entering it. Okay, part B goes on to a confidence interval question. Actually, this is quite an important exam technique, because even if you'd faltered on that first part of the question, we're now back possibly into something which we describe as slightly easier territory. The greengrocer also displays pears in trays. Each customer selects the pears he or she wishes to buy and puts them into a bag. A random sample of 40 such bags of pears at a mean weight of 0.86 and a standard deviation of 0.65. So that's from a sample. So X bar is 0.86. And the sample standard deviation is 0.65. I'm asked to do a 96% confidence interval. Some of you will get the value for the confidence interval from your calculator. My preference is to go back to the table that we had before, which I believe is table 4. Now, it's a central 96% confidence interval, so I'm going to need to look for 0.98 in my table. So 2.0537 is a number that I'm going to need in a moment. I'm going to make that really, really clear that I've got that value. I'm just going to check that again, 0.98. So if it's a central 96, it's going to be at 2% and 98%, and that's the value that I've just got from the table. So I'm going to use the formula, X bar plus or minus Z lots of S over root n, and I'm going to write 0.86 plus or minus 2.0537 lots of 0.65 over the square root of 40, because I'm looking at 40 such bags. Okay, my preference here is to write the 0.86 out again, and I'm actually then going to calculate what this value represents on the end. So 0.65 divided by the square root of 40 equals 0.10277, and I'm going to multiply that by 2.0537, and that gives me 0.211. So I'm going to add that to 0.86 and take it away to get my confidence interval. So 0.86 take away the answer that I got for the previous part. So the lower value of the confidence interval is 0.649 to 3 significant figures. And then if I do 0.86 plus 0.211, I'm going to get the top value, which is 1.071. And there's my confidence interval, nice and clearly. And that was for pairs, because I rather suspect that I'm going to need that later on in terms of some comment. So that was for pairs. For part 2, this is the final part, I believe, of the exam. Hence comment on the claim that the customers wish to buy on average a greater weight of apples than of pears. Well, if we go back to the first part of our question, X bar for the apples, determine the mean weight of a random sample of 10 such bags exceeds, sorry, I'm coming back up to you, I do beg your pardon. So the first part, normal distribution, our mu value, actually because this was from the population, is 1.16. And that was for the apples in the first part of the question. This is for the pears. Now what's going to be really, really useful for us now is this value here, which is 1.071. Hence comment on the claim that customers wish to buy on average a greater weight of apples than of pears. I think I'd agree with that, because if I look at the mean weight for the apples, it's actually greater than the upper quartile for that of the pears. So some evidence that the claim is valid as the upper limit of the confidence interval for pears is less than the mean for apples. And I think, I'm just looking back in the question if there are any other hints that we need to do. Just another tip for this type of question. There are 2 marks here, and both of them ask us to comment. Well, I've actually used the mean that was given previously in the question and the confidence interval, so I have used statistical evidence here. Quite often it will make reference here, and there'll be 2 marks, to using the sample and the confidence interval, so do ensure that you've made both. Because this is the last question, I'm just going to tick that one and suggest that I've done that one. I did that one before and that one. And now I'm going to have a look back through the whole paper and just check that I'm okay with everything. Best of luck for your exam, and I hope this has helped.